When dealing with differential air pressure monitoring and control between a Class 1 Division 1 room and an unclassified space, several factors must be considered to ensure safety and code compliance. If the controller is mounted in the unclassified space and only a reference tube is run into the classified area, the controller itself does not need to be intrinsically safe. The critical aspect is ensuring that the reference tube, which in this case is a 1/4-inch tube, does not compromise the Class 1 barrier. For the 1/4-inch reference tube not to compromise the Class 1 barrier, it must meet specific requirements. Firstly, the tube should be made of a non-sparking material. Stainless steel is a suitable choice because it minimizes the risk of sparks in a hazardous environment. Secondly, proper sealing at the point of entry into the classified area is essential. This prevents any potential ingress of hazardous materials into the unclassified area and maintains the integrity of the barrier. Thirdly, the routing of the tube is important to maintain its physical integrity and prevent potential hazards. The tube should be protected from being crushed or pinched, which could affect the pressure readings or even cause a leak. Several additional considerations should also be taken into account. Firstly, the reference tube must be connected to a suitable pressure sensor that is also non-sparking. This ensures that the entire system, from the point of pressure measurement to the controller, is safe for use in a hazardous environment. Secondly, regular calibration and maintenance of the tube and sensor are necessary to ensure accurate readings. Changes in temperature, pressure, or the presence of contaminants can affect the accuracy of the sensor, so regular checks are vital. Thirdly, consider using a barrier device between the controller and the pressure sensor to further enhance safety. A barrier device limits the energy that can travel from the unclassified area into the classified area, providing an additional layer of protection. These recommendations align with the National Electrical Code, specifically Article 500.52 that is B1, which discusses the general requirements for equipment in hazardous locations, and Article 501.102 that is B4, which pertains to wiring methods in Class 1, Division 1 locations. Understanding and adhering to these codes is crucial for ensuring the safety of the installation. To elaborate further on the material selection for the reference tube, stainless steel is preferred not only for its non-sparking properties but also for its resistance to corrosion and chemical degradation. In Class 1, Division 1 environments, where flammable gases or vapors may be present, the materials used must be able to withstand these conditions without deteriorating or posing a risk of ignition. The sealing of the reference tube's entry point into the classified area should be done with a suitable sealant or fitting that is approved for use in hazardous locations. This ensures that the seal is gas-tight and prevents the migration of flammable substances. The routing of the reference tube should also consider potential sources of mechanical damage. It should be protected from impact, abrasion, and other forms of physical stress. This may involve using conduit or other protective measures to shield the tube from damage. The pressure sensor connected to the reference tube should be selected based on its suitability for use in hazardous locations. It should be certified as intrinsically safe or explosion-proof, depending on the specific requirements of the application. Intrinsically safe sensors are designed to limit the amount of energy that can be released in the event of a fault, while explosion-proof sensors are designed to contain any explosion that may occur within the sensor housing. Regular calibration and maintenance of the pressure sensor are essential for ensuring accurate readings. This involves checking the sensor's output against a known standard and making adjustments as needed. The frequency of calibration will depend on the specific sensor and the application, but it should be done at least annually. The use of a barrier device between the controller and the pressure sensor can provide an additional layer of safety. Barrier devices limit the amount of energy that can travel from the unclassified area into the classified area, reducing the risk of ignition. There are several types of barrier devices available, including Zener barriers and galvanic isolators. Zener barriers use Zener diodes to limit the voltage and current that can pass through the barrier, while galvanic isolators use transformers to isolate the two circuits. When selecting a barrier device, it is important to choose one that is compatible with the pressure sensor and the controller. It is also important to ensure that the barrier device is properly installed and maintained. In addition to the above considerations, it is also important to follow all applicable codes and standards when installing a differential pressure controller in a Class 1, Division 1 environment. This includes the National Electrical Code, as well as any local codes or regulations that may apply. Proper documentation of the installation is also essential. This includes maintaining records of the equipment used, the installation procedures followed, and the calibration and maintenance performed. This documentation can be helpful in the event of an inspection or audit. To summarize, when installing a differential pressure controller for monitoring and controlling air pressure between a Class 1, Division 1 room and a non-classified space, ensure that the controller, if located in the unclassified space with only a reference tube entering the classified area, does not need to be intrinsically safe. The quarter-inch reference tube should be made of a non-sparking material like stainless steel, properly sealed at the entry point, and routed to prevent damage. Use a non-sparking pressure sensor, calibrate regularly, and consider a barrier device for enhanced safety, complying with NEC Article 500.5(2) that is B1 and Article 501.10(2) that is B4. Furthermore, the selection of materials, especially for the reference tube, should prioritize corrosion resistance and the ability to withstand chemical degradation prevalent in Class 1, Division 1 environment. The sealing of the reference tube's entry point must utilize fittings approved for hazardous locations, ensuring a gas-tight barrier against flammable substances. Protective measures, such as conduit, are advisable to shield the tube from mechanical damage, preserving its integrity and function. The pressure sensor, crucial for hazardous location applications, should hold certifications for intrinsic safety or explosion-proof characteristics. These sensors are designed to either limit energy release during faults or contain explosions within their housing, respectively. Regular calibration of these sensors is paramount, with the frequency tailored to the sensor type and application, ideally performed at least annually. Barrier devices, like Zener barriers or galvanic isolators, further enhance safety by restricting energy transfer between classified and unclassified zones. Proper selection and maintenance of these devices are vital for their effective operation. Compliance with the National Electrical Code, alongside local regulations, is non-negotiable, demanding meticulous documentation of equipment, procedures, and maintenance activities to facilitate inspections and audits. When the controller is installed in an unclassified space, running a reference tube into the Class 1 Division 1 area, the focus shifts to ensuring the safety and integrity of the components within the hazardous environment and the barrier between the two zones. Here's a more detailed breakdown. Firstly, the controller itself, if located outside the classified area, does not require intrinsic safety features. However, all components within the Class 1 Division 1 area or directly interfacing with it must adhere to stringent safety standards. This includes the pressure sensor, any associated wiring, and the reference tube itself. Secondly, the reference tube is a critical element in this setup. Its primary function is to transmit pressure from the classified area to the sensor without compromising the hazardous environment. Material selection is paramount. The tube must be constructed from a non-sparking material. Stainless steel is commonly used due to its durability, corrosion resistance, and non-sparking properties. Avoid materials like copper or aluminum, which can generate sparks under certain conditions. Thirdly, the diameter of the tube, in this case a quarter-inch, is generally acceptable, but the key is ensuring a proper seal at the point where it enters the classified area. This seal prevents the migration of hazardous substances from the classified area into the unclassified area. Use a suitable sealant or fitting that is specifically designed and approved for use in hazardous locations. This fitting should create a gas-tight seal to prevent any leakage. Fourthly, the routing of the reference tube is another important consideration. The tube should be protected from physical damage, such as being crushed or pinched. Use appropriate supports and clamps to secure the tube along its path. Avoid routing the tube in areas where it could be exposed to excessive heat, corrosive chemicals, or other hazards. Fifthly, the pressure sensor connected to the reference tube must be suitable for use in a Class 1 Division 1 environment. This typically means that it must be either intrinsically safe or explosion-proof. Intrinsically safe sensors are designed to limit the amount of energy that can be released in the event of a fault, preventing ignition of flammable substances. Explosion-proof sensors are housed in enclosures that can contain an internal explosion without igniting the surrounding atmosphere. Sixthly, wiring and connections within the classified area must also comply with Class 1 Division 1 requirements. Use appropriate wiring methods such as conduit, and ensure that all connections are properly sealed to prevent the ingress of hazardous substances. Seventhly, a barrier device can provide an additional layer of safety. A barrier device limits the amount of energy that can flow from the unclassified area into the classified area, further reducing the risk of ignition. There are two main types of barrier devices: Zener barriers and galvanic isolators. Zener barriers use Zener diodes to limit voltage and current, while galvanic isolators use transformers to provide electrical isolation. Eighthly, regular calibration and maintenance are essential for ensuring the accuracy and reliability of the pressure monitoring system. Calibrate the pressure sensor regularly according to the manufacturer's recommendations. Inspect the reference tube and fittings for any signs of damage or leaks. Replace any damaged components immediately. Ninthly, documentation is crucial for demonstrating compliance with safety standards. Maintain detailed records of all equipment used, installation procedures, and maintenance activities. This documentation can be invaluable in the event of an inspection or audit. Tenthly, it is important to consult with a qualified professional who has experience in designing and installing systems in hazardous locations. They can provide guidance on selecting appropriate equipment, ensuring proper installation, and complying with all applicable codes and regulations. In summary, while the controller itself may not need to be intrinsically safe if located outside the classified area, all components within the Class 1 Division 1 area or directly interfacing with it must meet stringent safety standards. Proper material selection, sealing, routing, and maintenance are essential for ensuring a safe and reliable pressure monitoring system. Additionally, consider using a barrier device for enhanced safety and consult with a qualified professional to ensure compliance with all applicable codes and regulations.